Math 3, Practice 3.3.2, using trig functions to model periodic phenomena. Okay, and an extra worksheet that we were given about graphing. Okay, so these first ones we're just writing our functions. Okay, so it says a sine curve that is shifted pi thirds units to the left has a midline at y equals 2 and rises 4 units above the midline. The length of one cycle of its curve is 2 pi. So the idea is that we go a times the sine, the amplitude times the sine of b times a phase shift plus k. Alright, that doesn't look like much like a k. So it's a sine. So first thing is my a. So I'd go f of x equals my a, 4, okay, times the sine of my one cycle of its curve is 2 pi. So I'd go 2 pi times x. Then it says it's shifted pi thirds units to the left. Remember, whenever we do a horizontal shift inside of parentheses, we always do the opposite. So it would be plus pi over 3. Then we would go the midline at positive 2 plus 2. And that's our equation. Except for I made one major mistake. I forgot that the period is actually 2 pi over b would equal 2 pi. So b would have to be 1. So it would be 1 times, or we can rewrite that better. It would simply be 1 times x plus pi thirds, or pi thirds over 2, or plus 2. There we go, that's better. Okay, number 2 says a sine curve with no horizontal shift. Okay, so we don't have that one this time. Has a frequency of 2 over pi. Remember, frequency is b over 2 pi, would equal 2 over pi. Okay, so cross multiply, 4 pi equals b times pi, divide by pi, and we'd get 4 equals b. Okay, rises 3 units above its midline, so a equals 3. Midline is 1. So we'd go f of x equals 3 times the sine of 4x plus 1. Okay, now 3 says a cosine curve has 2 consecutive maximum points at pi fourths and 4 and 3 pi fourths and 4. So if you think about that graphically, pi fourths would be right here. 3 pi fourths would be right here. Okay, so it would go down something like that. So that period would be pi fourths to 3 pi fourths, which would basically be 2 pi fourths, right? That distance, which we'd reduce to pi halves. So my period is pi halves, meaning b would be 2 pi over b equals pi over 2 times again, and we get 4 pi equals b over pi, so it would be 4. Our b would equal 4. Okay, and a minimum point at pi halves negative 6. Okay, so for our midline, we go up to 4, down to negative 6. So at negative 1 would be our midline. Okay, which means negative 1 to 5 would mean our amplitude is 5. Okay, and then it's been shifted because it's not starting out at 0, 4, it's been shifted that much. So I'd go f of x equals 5 times the cosine of b was 4, 4 times x minus pi fourths. It's a minus in there. And then minus 1. So that one was kind of crazy, wasn't it? But there we go with that one. Okay, now these ones we're doing the same thing, but with the graph instead. So for 4, we can probably see that midline's at negative 2, which means my amplitude is 1/2. Okay, then we start on the midline, so it means it's a sine function. So 1/2 times the sine. Okay, because it started right there with that normal one, we know there's no phase shift. And it looks like we go a period of pi fourths. So I'm going to go 2 pi over b equals pi over 4. So that gives me 8 pi equals b times pi. Pi's will cancel, so 8x minus 2. Okay, number 6. I have 2, negative 4, so midline is at negative 1. So k equals negative 1, which means amplitude is 1, 2, 3. Okay, now notice this one, we start on the midline, but we go down. Okay, so that would be an amplitude of a negative 3 instead of going up. So a period goes till we get to 4, so my period is 4. So for b, it would be 2 pi over b equals 4. Okay, so we need b to have a pi in it, so the pi's would cancel out. Okay, but to get it to equal 4, okay, think of it this way. 4 times b equals 2 pi, divide by 4. So we'd have 1 pi over 2 or pi over 2 for b. Okay, so because it's starting on the midline, it looks like there's no phase shift here, so I'd go f of x equals negative 3 times the sine of pi halves times x minus 1. Okay, number 5. Hopefully we can see that midline's right there. Okay, now depending on what phase shifts we did, we could probably make these problems cosine problems as well. But I say go with the one that makes the most sense, the simplest. So I look at this one, going down again and then up. So I'm going to call this another sine. Okay, my amplitude would be 1, but it'd be a negative 1, so negative 1 sine. Okay, my period went to 2 pi, so that's just b is 1. So x, and then my midline's up 3. That's one option I could have. Okay, now let's say we thought of this as a cosine problem. Okay, if it's a cosine problem, well, cosine always starts right here. Okay, so I've shifted it over to the right pi halves. I still have the same period, I still have the same amplitude, I still have the same midline, so it would be negative 1 cosine of x minus pi halves plus 3. Okay? So either one would work that way. Okay, number 7. So midline here looks like a 1, right? So an amplitude of 2. We're going down, so I'd call it negative again. Or we could think of it in terms of a sine or a cosine. There's a lot of different ways we could think of this. But I prefer to say let's make it negative for our amplitude. So then it goes up, comes back down, so period of pi halves, which in order to get that, our b has to be ends up being 2 pi over b equals pi halves. So 4, because we've dealt with this one before. Okay, right? The pi's cancel out. 2 times 2 is 4. So I would go negative 2 sine of 4x plus 1. All right? So there's those ones. Okay. Now, 8 says, when Eve released a spring, it completed one oscillation, one cycle, per second and traveled up to 4 inches from equilibrium. She knows the oscillation can be described by a cosine function with no horizontal or vertical displacement. So we have no k, we have no phase shift. So it would be 4, because right, times the cosine of something x. And that's going to be the toughest part. It's going to be something pi x2. The reason I know that is because to get that oscillation, so that oscillation is basically the frequency. So it'd be b over 2 pi. Okay, we need that to equal 1, and so the only way that's going to be is if it's 2 pi. Okay, so I guess this is where that frequency comes into play. 9 says Brandon played a note on his clarinet that had an amplitude of 2 and a frequency of 740 hertz. He knows this note can be described by a sine function with no horizontal or vertical displacement. So we've got 2 times the sine of, now that hertz, believe it would be that same thing, that b over 2 pi would have to equal 740. So basically it'd be b equals 2 pi times 740. So those two would give us 1480 pi. So 1480 pi times x. 10 says, since January 2005, the average monthly temperatures of Swansburg have fluctuated in accordance with the function shown in the following graph. Write an equation. Okay. So let's find the midline. We start down here at 6, go up to 24. Okay, so half of that would be 15. So there's our midline, k equals 15. So our amplitude is 9. Okay, notice we don't start here or here, so there's a phase shift going on. Okay, so I could go 9 times the cosine, or I could go 9 times the sine. Let's think in terms of cosine first. If cosine were it, this would be back here on that. So we've got a phase shift of 1. Okay. That would give us a negative 9 for our amplitude. So if we wanted it to be positive, we'd have to go clear up to here, which would be 7. So it'd be x minus 7 here. Midline of 15, so it'd be plus 15. Now we need to see what our period does. From here 1 till we get to 13. So it has a period of 12. So period of 12 would mean 2 pi over b would be equal to 12. So 2 pi equals 12 times b. Divided by 12. 2 over 12 is 1 over 6. So it would be pi over 6 right here. Okay, there's one version. If I did sine, that means this would have to be our starting point. So that would be 4 for a phase shift. The period would be the same. So it would be pi over 6 times x minus 4 plus 15. And there's the difference. And there we go. Oh, now to the graphing. Okay? So now when we're graphing, it's kind of just working the opposite way. Okay? So you've got to remember, however, the standard form for sine. So for sine, thinking back to that unit circle, right? What our values are when we're at 0, 90, 180, 270, and 360 means that for our function, we have a midline of 0. So we start here at 0, 0, and then at pi halves we go up to 1, a pi back to our midline, 3 pi halves down to negative 1, and then 2 pi. And we keep going in that fashion. Okay? Okay, but we're really only worried about doing one period, so we can end it right there. So now the difference is we've got a minus 1, so our midline is shifted down here. So that means every point would shift down 1. The problem is we have an amplitude of 4. So instead of just shifting down 1 and being done, we have our midline points right here at 2 pi, pi, and 0. But when we go to pi halves or 90 degrees, we're going to go up 4 instead, from the midline. So we'd get up there to 3. So it'd be right here. And then we'd go down 4 right here, and then these would be our points on the midline. So our new graph would look something like this. Okay? So, same with number 2, we always think in terms of where that standard one is for sine, and maybe I'll hurry and put that. That's what the standard one would look like on each one. So in this one now we have a 3 right here. Okay, so our midline shifts up to 1. Our amplitude is the same, but that b is going to change our period. Normally a period is 2 pi. We're going to go 2 pi over 3. Okay, that's how, because we can't simplify that further. That would be our period. So what that means is we're going to repeat every 2 pi over 3. The way we deal with that is we shift it up to our starting point. Okay, normally our ending point is 2 pi away, but we're going to go 2 pi thirds away. Okay, so the easiest way I can say to explain it is if pi is right here, okay, pi thirds would cut this into thirds. So this would be like pi thirds. This would be like 2 pi thirds, and then 3 pi thirds. So my ending point is going to be at that 2 pi thirds, which be about right there. Okay, now on our regular one, the middle line of pi between the first and the end is halfway in between on that midline. So I'm just going to guess about halfway between on that midline. Then our first point is usually halfway between the first and the third, and our last between the third and the fifth. So because my amplitude is 1, I'll go up 1 about halfway, down 1 about halfway. My graph will look like that. I'm kind of just estimating on some of these when my period is kind of crazy. Okay? So let's look at number 3. So number 3, my midline's a -1, so it shifts down to -1. So I'm starting down here at -1. Now I've got an amplitude of 2, so when I start going up, I'm going to go up 2 and then down. But I've got to figure out what my period is going to be. My b is 1/3. So for my period, I go 2 pi over 1/3, which we should remember what we do here. I can't divide by 1/3, so we multiply by the reciprocal. So I get 6 pi. So I'm going to end at 6 pi, okay, on my midline. Then halfway between, I'm on my midline, so at 3 pi, I'm halfway between. Then for this next one, I'm halfway between that, so right about there, but I'm going to go up 2. And then on my last, I'm halfway between, but I'm going to go down 2. And there's my graph. Okay? Now for 4, 5, and 6, it's the same idea, though this time we're dealing with cosine. Cosine starts up here at 1, then at 2 pi we hit the midline, then down at pi we go to the bottom one, then at 3 pi halves midline, and at 2 pi. And there's one period for that. So in this, I don't have a change in amplitude. My midline shifts down 1. My period changes. So I go 2 pi divided by 4, which gives me pi halves. So what that means is I'm going to start 1 up from my midline at 0, and I'm going to end 1 up at pi halves. Halfway in between, see how we've got starting, ending, then halfway in between below 1. So halfway between would be pi fourths, so I'm going to go down 1. Then halfway between those two, I'm at the midline, and those two I'm at the midline. So I kind of estimate halfway I'm at the midline, so it looks something like that. We'll just keep repeating itself every time if I wanted to keep drawing it. But I don't need to. I just need that one. Okay? So, 5 and 6. So let's draw our parent graph here. and our parent graph here. Okay. Now in this one, amplitude of 1/2. Okay. Midline at +2. So I'm starting up here at +2, but instead of starting 1 up, I'm going to start at 1/2 up. And I will end, because I'm not dealing with my period, I'll end at 2 pi 1/2 up. Then at pi, I'm halfway down. Pi 1/2 still on the midline. 3 pi 1/2 still on the midline. So it looks like that. Okay. Now the last one, my midline shift is down to -2, so we shift down to -2. Amplitude of 3, so I'm going to start 3 up. Okay, I'm also going to end 3 up, which where do I end? Well, that's 1/2 for my b, so 2 pi divided by 1/2. It's really like 2 pi times 2 over 1, so 4 pi. So my ending up there is at 4 pi. Then halfway between 0 and 4 pi, so at 2 pi, I'm going to go down my midline 3. Okay. Then pi, which would be halfway between 0 and 2 pi, and 3 pi, I hit the midline. So my new graph looks something like that. Okay. Now, by all means, you can use a graphing calculator to graph these. However, sometimes it's hard to get the window right in your graphing calculator. So, there we go.